Kelt 9b is one of the hottest planets ever discovered. It is located about 670 light-years away and belongs to a category called ultra-hot Jupiters. Its dayside temperature reaches nearly 4,300 degrees Celsius, which is actually hotter than the surface of many stars. At this extreme heat, molecules cannot stay stable. Hydrogen gas in the atmosphere breaks apart into individual atoms, and heavier elements like iron and titanium can exist as vapor. Because the planet orbits very close to its star, it completes one full orbit in just 1.5 days. This intense radiation is slowly stripping away its atmosphere. The gas escapes into space, forming a long tail similar to a comet. Over time, this continuous loss of mass could significantly change the planet's structure. The environment is so extreme that even basic chemical bonds struggle to exist, making it a place where matter behaves very differently from anything seen in our solar system. WASP-12b is a planet being actively pulled apart by its own star. Located about 1,400 light-years away, it orbits so closely that the star's gravity stretches it into an egg-like shape. This distortion is caused by tidal forces, similar to how the moon affects Earth's oceans, but far more extreme. Every second, the star pulls in about 6 billion tons of material from the planet's atmosphere. This gas forms a glowing stream that spirals into the star, slowly feeding it. The planet's outer layers are no longer stable and are continuously being lost. Because of this constant mass loss, WASP-12b is expected to shrink over time and may eventually disappear completely. There is also a possibility of gravitational interactions with other nearby bodies, which could destabilize its orbit further. This planet is a clear example of how powerful stellar gravity can completely reshape and even destroy nearby worlds. HD 1897-33b is a gas giant that looks calm from a distance but is extremely violent up close. It appears deep blue in color, but this is not due to water like Earth's oceans. Instead, the color comes from silicate particles in its atmosphere which scatter blue light. The planet experiences temperatures of around 930 degrees Celsius, hot enough to melt many metals. What makes it even more extreme are its winds, which reach speeds of about 8,700 kilometers per hour. These winds carry tiny glass particles across the atmosphere, creating sideways storms of sharp, molten shards. Instead of rain falling downward, it blasts horizontally at incredible speed. The planet is tidally locked, meaning one side always faces its star while the other remains in darkness. This creates a huge temperature difference that drives these violent winds. Observations from the Hubble Space Telescope confirmed these conditions, making it one of the most well-studied and hostile exoplanets known. WASP-76b is a planet where metal behaves like water does on Earth. It is located about 640 light-years away and is also tidally locked, so one side constantly faces its star. On this day side, temperatures reach around 2,400 degrees Celsius, which is hot enough to vaporize iron. This creates an atmosphere filled with iron gas instead of typical elements like water vapor. Strong winds then carry this vapor toward the cooler night side. As the temperature drops, the iron condenses and falls as liquid metal rain. This process is similar to Earth's water cycle, but involves molten iron instead of water. The continuous movement of heat between the two sides drives powerful atmospheric circulation. The result is a planet where clouds, rain, and weather exist, but in forms that are far more extreme and dangerous than anything on Earth. It shows how familiar processes can occur under completely alien conditions. Korot 7b is a rocky planet with conditions so extreme that its surface is partially molten. It is located about 520 light-years away and is classified as a super-Earth. The planet orbits very close to its star, causing its dayside temperature to rise high enough to melt rock into lava. This creates vast oceans of molten material instead of water. Unlike Earth, Korot 7b has little to no atmosphere, so there is nothing to distribute heat evenly across the planet. As a result, the night side remains extremely cold and solid. The lack of atmosphere also allows vaporized rock from the dayside to travel and condense, possibly forming rock-based precipitation. This creates a cycle where material evaporates, moves, and falls back onto the surface. The planet is likely tidally locked, which means one side constantly experiences intense heat while the other stays frozen. It is a clear example of how rocky planets can exist in conditions far beyond anything seen in our solar system. Trieste 2b is known as one of the darkest planets ever discovered. It reflects less than 1% of the light that hits it, making it darker than coal. Despite orbiting close to its star, it does not shine brightly because its atmosphere absorbs almost all incoming light. The planet has temperatures exceeding 1,000 degrees Celsius, which should normally produce a glowing appearance. However, the presence of elements like sodium and potassium in vapor form absorbs light instead of reflecting it. This gives the planet its extremely low reflectivity. It is also tidally locked, meaning one side is permanently facing its star and remains extremely hot. The other side stays cooler, but still does not reflect much light. Scientists believe that the lack of reflective clouds and the composition of its atmosphere are responsible for its darkness. Even though it is very close to its star, it appears almost invisible against the blackness of space, making it one of the most unusual exoplanets discovered. Gliese Gliese 436b is a planet where ice exists in conditions that seem impossible. It is located only about 33 light-years away and has temperatures around 439 degrees Celsius. Under normal conditions, ice would instantly melt at such high temperatures. However, the planet's gravity creates extreme pressure in its interior, forcing water into a solid form known as hot ice, or Ice X. In this state, water molecules are compressed so tightly that they remain solid, despite the heat. The planet is similar in size to Neptune and is surrounded by an atmosphere rich in carbon monoxide and other gases. Its structure likely includes a dense core surrounded by layers of this unusual ice. This combination of high temperature and high pressure creates an environment where the usual rules of matter no longer apply. It demonstrates how different physical conditions can produce forms of matter that do not exist naturally on Earth.